Alright, in this video I am going to go over problems 16 through 20 from the Exam 1 review. So on the first one here you have Sam needs to get a B in chemistry to keep his scholarship. So his grade is based on four 100-point exams. If he has scores of 80, 74, and 88, what score will he need on the fourth exam to earn a B in the course? Alright, so let's look at this. First of all, how do you find the average of four numbers? Or at least that's what we're looking at here. There's going to be four tests. We know three of them. So we take the four numbers, we add them, and we divide by 4. And that needs to equal, well, see, if he needs a B, that needs to equal 80. Alright, so let's go ahead and add those numbers in the numerator of this fraction, 80, 74, and 88. If you do that, you get 242. So now let's think about this. We could actually change that box to an X, and we could use algebra to solve this. So that's certainly a possibility, but let's reason this out. Think about this. If you have 6 divided by 3 equal to 2, then it must also be true if you go in reverse. Hold on just a second here. Notice 3 times 2, or 2 times 3, should equal 6. So in this case, look at our numerator. If you take that and divide by 4 and you get 80, it must be true that 80 times 4 is going to equal that numerator. So 80 times 4, that's 320. So we know that 242 plus this other number needs to add up to 320. Alright, so if you subtract 242 from 320, you'll see your answer is 78, and that is our answer. Now if you wanted to check this, it'd be very easy to do that. Just add that 78 with the other three numbers and divide by 4. Then you'll see that that is 80. Let's move on to the next problem. So in this problem, I'm not going to read it to you this time, but we know that we need miles per gallon. And so if you look at the two odometer readings, if we subtract those, we'll find out how many miles we traveled, and we were told how many gallons we used. Let's go ahead and do the subtraction here. So we traveled 341.5 miles, and we used how many gallons? 15.7. So if we write 341.5 miles over 15.7 gallons, when we simplify this, we'll get our miles per gallon. And so when you do that, you get about 21.8. Now we also had to find miles per hour, and so we need to write the number of miles divided by the number of hours, which we're told was 6. So when you do that division, you get 56.9. That's pretty close to 57. We'll just call it 57 miles per hour. Alright, that's on average. Let's go on to the next problem. So you got to read this one kind of carefully. Notice that you have a traffic counter, and it's counting the number of axles that cross this line. So for an auto which has 2 axles, you're going to get 2 counts, and for trucks, bigger trucks, you're going to get 3 axles or 3 counts. So we're told that there was a total of 41 counts. So we have to have some combination of 2 count and 3 counts that adds up to 41. So let's see. Well, let's start by using, well actually let's make a table first, and that'll help us to kind of keep track of this. We're going to start with one truck, because I'm going to guess that we'd have more cars or autos than trucks. If we had one truck, then our count for that one truck would be 1 times 3. Each truck has 3 counts. And we need to add to that the number of counts from the autos, and that needs to add up to 41. So if we do 41 minus 3, that's what we get from the one truck. We need 38 counts. Well, it's 2 counts per car, so if we divide by 2, we get the number of cars. So it'll be 19 times 2. If you take 1 times 3, which is 3, plus 2 times 19, which is 38, you do get 41. So that's our first case. Alright, so now let's try 2 trucks. So we'd have 2 times 3 plus, we need to look at the number of counts for cars that we need. So if you subtract, let's see, 2 times 3 is 6. 41 minus 6, we need 35 counts from our cars. Now think of this, we get 2 counts per car, so we need an even number in order for this to work. So this case isn't going to be possible. Can't get cars to get an odd count, which is what we're needing here. So let's try 3 trucks. So it'll be 3 times 3, so we need to take 9 from 41. So we need 32 counts from the cars, so divide by 2, and so we're going to need 16 counts there. And again, you could take 3 times 3 plus 16 times 2, 9 plus 32, that is 41, so it does work. Let's move on to 4 trucks. So 4 times 3 would be 12. We need to subtract 12 from 41. We get 29. The same problem we had when we had 2 trucks. We can't get 29 counts from the cars because cars have 2 counts each. We got to have an even number here. Alright, so we're going to also cross that possibility out. Let's move on to 5. So it'll be 5 times 3, which is 15. Let's subtract that from 41. We get 26. So if you divide that by 2, you can see we need 13 cars, or 13 autos. And again, if you check that, you get 15 plus 26, which does add up to 41. So at this point, you start seeing a pattern. We would expect the next case to have 7 trucks. Look at our autos. In these 3 cases here, it looks like we're going down by 3. So we would expect to get 10 here. Let's go ahead and do this. And if you verify it, notice 21, 3 times 7 plus 2 times 10, 20, that works. That is 41. So we have a pattern here. We're looking at odd numbers, 1, 3, 5, 7, and notice each time our autos is decreasing by 3. So this just makes it go a little bit faster. So we're going to have 9 trucks and 7 autos. We're going to have 11 trucks, and let's see, 7 minus 3 would be 4. So we're going to get 4 autos. 11 trucks, 4 autos. Let's keep going. 13, 4 minus 3, 4 minus 3 is going to be 1. And so this would be our last case. Notice, again, 13 times 3, that's 39. Plus 2, that does give you 41. So these are our cases. We got 1, 2, 3, 4, 5, 6, 7. I actually have 7 cases here, 7 possibilities. So there is not a single answer to this problem. There's actually 7 possibilities. Let's move on to the next problem. So here we know that 1 yard is 3 feet, and we need to find out how many what 1 square yard would equal in terms of square feet. Well, one way to approach this problem is think of it as an equation and let's square each side, because I need square yards and I'll have to square the other side. Whatever you do to one side, you do to the other. So we're going to multiply 1 yard times 1 yard and 3 feet times 3 feet. Notice you get 1 square yard. Yard times yard is yard squared. On the other side, you get 9 feet squared. So 1 square yard is equal to 9 square feet. You could also do this visually. Picture a square that's 1 yard by 1 yard. So that's equivalent to 3 feet by 3 feet. And when we do length times width, we're going to get 3 feet times 3 feet, which is, again, 9 square feet. All right, let's move on to number 20. All right, so we have 12 white socks and we have 5 black socks. So as I'm picking socks out of my drawer, I need to find out the worst case. What's the longest it could take me to get 2 white socks? Well, it's very possible, not likely, but it's quite possible that you could pull out all the dark socks first. This is like, or the black socks, this is like the worst case scenario. You're trying to get 2 whites, but you get a black, another black, another black, another black, and another black. So worst case scenario, the first 5 draws, you're getting all black socks. So finally, on your 6th draw, you're getting a white, and 7th, you're getting a white. So at the longest it could take is 7 times before you finally get 2 white socks. But more than likely, you would get it sooner than that. But this would be your worst case scenario. So that's the last 5 problems. I hope that helps. And that's it.